subject of histograms, the one that seems to put fear into many students. They're not that difficult. They're quite easy to actually draw. Getting data from them is sometimes a little bit more difficult. But we'll have a little explore and see what we can do with this. So let's start trying to draw ourselves a histogram from some data. Let's have a go. So the first thing I want is some data so that I can try to sort of give us a bit of a histogram. And let's take some data here, and we're trying to get to school perhaps, and we're looking at the time taken to get to school. And let's draw ourselves a little table of this data, and the first two columns I'm going to put in are time. So this is going to be from, I know they're going to take from 25 minutes to 30 minutes. Then we've got from, I know, let's have 30 minutes. This, I know this isn't going to quite work because I should have less than and greater than and equal to. We're just going to ignore that for the time being. Let's go for 35 to 40. Then let's do something silly. Let's change the range here. Go from 40 to 50, and then we could go from 50 to, I know, 80. So now we've got to try and put in the number of students that will do this, and this is going to be our frequency. So let's just put in some random numbers here: 55, 39, 68, 32, and we'll have not many here, 6. Okay, now before we can actually do anything in a histogram, what we need to do is to measure something called the class width. This is our class that we're looking at, and we're trying to look at how many numbers here. So this is going from 25 to 30, so it's going to be 5. This is 30 to 35, it's also going to be 5. 35 to 40, 5. Then it changes. 40 to 50, that's going to give us 10. And 50 to 80, that's going to give us a whopping 30. Having drawn in our class width, then our next one we need to try and do is work out something which is called our frequency density. So let's have a little look about what is frequency density. So our frequency density this simply equals our frequency divided by our class width. So for each of these, if we have a look at them, then this is going to be our frequency 55 divided by 5, which is going to give me an easy answer here of 11. Now, I thought about that one. The next one I didn't think about. I just put in 39 divided by 5, and that gives me a grottier number. So for that I've got to do some work. So I've got to do simply 39 divided by 5, and that's going to give me 39 over 5. Really useful calculator. 7.8. My next one is going to give me 68 divided by 5, and that on the calculator is going to give me 13.6. We've then got 32 divided by 10, and that one's going to be really easy. That's going to give me 3.2. And the last one is 6 divided by 30, so that's going to give me 0.2. I left myself some that I could actually work out. Right, now there's all our data. What comes next? Well, we've obviously got to try and graph this somehow, so we're going to try and put this. So what I need is graph paper, and let's take out a sheet of graph paper and let's have a go at trying to draw this and see what happens. Okay, so I've got my graph paper. Now let's, rather than starting to draw this straight away, let's start by having a little think about what we're doing. We've got our times here, and that's going to go from really 25 to 80, and so as long as I've got that in there, that's all right. So I'm going to go from 25 here to 80, and on this side we're going to put in the frequency density, and that's going to go from 0, because it's 0.2, up to probably about 14. Now I've got an idea about my scale, let's see what we can do about that. So let's put this piece of graph paper in, and I'm just going to zoom out so you can see more what I'm trying to do here. Right, we've got a height of about 14. Let's count the number of squares. So we've got simply, if I start at 0 there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I could just about do it, but I'm going to probably set that about 7 long, and I've got plenty of width here, so we'll start here. So we've got 7, 1, 2, 3, 4, 5, 6, 7. Going across, then, if I say this is going to be 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80. So we've got enough space here to do that. Right, let's go in and put some data in. If I say this is 25, that's 30, 35, 40, 45, 50. It's a good idea to make sure that basically we've got a very even scale when we're going along here. So I've got my numbers along there, and we can put our numbers up here. So this is going to be 1, 2, 3. So I've got now some sort of scale ready to go. Our first set of data that we've got is we're going to start from 25 to 30, so that's going to be its width, and we're going to have a frequency density of 11. I'll zoom out just a bit so you can see that. Right, so we're going to start at 25 and we're going up to 11, and so I'm just going to draw the ruler along the top. It's 5, so we can draw the ruler along here, and let's put in the first bar. There we go. Now my second bar is in fact going to be 7.8, so it's going to be less. So let's take this one, let's draw that one in, and we want to go now to about 7.8. That's what my next one was, 7.8. I can read it on the piece of paper. 7.8, and it's 5 across. My problem is I haven't fixed the piece of paper down, so it's moving around. Going along all right. This is looking like a typical bar chart really, and then we've got this massive 13.6. So let's go up to 13.6, let's put it in, there's my marker, and I'm just going to draw the line up there. And it's important trying to make sure that you do try to use a ruler for this to make it look good. I'm going to bring this one right down to the bottom. So we've got that one there. And our next to last one is 3.2, but it's a class width of 10. So 40 to 50 is going to be 3.2. So there's my 3.2. Draw this one in. And a class width of 10 here. And the last one is 0.2, very low amount, and this time a class width of 30. So we're going to go only this small amount up. And we'll finish it off. So there is my completed bar chart. And it's not too bad. We will need to try and put some things on there. So along this side we're going to write our frequency density. And along the bottom we have our time in minutes. And so that's the time taken for everyone to go to school. And I could give it a nice title here to say what it is, the time taken for so many students to basically get to school. Now let's have a look and see what other data we can play around with on this, because what they're going to do is they're going to typically ask you nasty questions on this data. So they could ask you, well, how long did it take for some students to get from to get to school doing this sort of time. So let's say how many students took between something grotty. Let's go for 36 minutes to 45 minutes. There. And we've got to work out what that is. Well, that doesn't look very nice, because what I'm after is looking at a peculiar amount that doesn't quite fit in where we're going. So we're going up to 45, so I want all the students that are, perhaps that wasn't my best colour to choose. I wanted something faint though. So I want that lot, and we want to go from 36 so it's also going to be all of that lot, but not anything else. So I've got to find now that number. Okay, so let's look at each of these. Zoom in a bit. Right, so looking at this data, let's look at each of these plots in turn. So I've got this number, which is from 36 to 40. And that range here is going to be multiplied by the height, which we said earlier was 13.6. And I'm going to then add that to the next bit, which is all those students from 40 to 45. That range, and I'm going to multiply that by the number in that range, which is 3.2. So if we do our sum here, we've got simply 4 here times 13.6, and this one will have 5 times 3.2. I'm going to need to do this on the calculator, so let's zip over to the calculator and do this sum. This is going to be then, I don't need to do this one in brackets, but I will, so I'm just going to do 4 times 13.6, and I'm going to add that to 5 times 3.2, and that's going to give me 352 over 5, or 70.4 students. So that's going to tell me the number in this green splodge. And we've managed to work out a simple histogram. So drawing histograms is generally not too difficult. It's not one of the worst things we can actually come across. What is more problematic is trying to work out other things from it. And that's why we use histograms, so we can actually do these sort of things. Where do histograms get used? They get used in statistics a lot. They get used by people trying to sort of show how many are doing this, that and the other. And it's sometimes better to do a histogram because it gives an idea of the area rather than just something that is just sort of a number. And so in some ways it's a bit more realistic having a look at that sort of data. So there is a histogram drawn, and it gives you some idea of what it might look like. So let's try and make sure that we can do these things. The y-axis is always the frequency density. We've got the x-axis with whatever we're trying to look at. We make sure that the height of the bar is the frequency density for each one that we're looking at, and we make sure the bars have no gaps between them. So we can try various other ones and draw bits and pieces from these, but they're all basically the same. So our next job is really to try and see if we can interpret a histogram, whether we can actually get some data from it. And that's where it starts getting a little bit more difficult when we try to do this. So maybe we've got a histogram and we're trying to get data like this, and that's how we get these nasty little things like this to work out the number of people that are between this and this. So we can try to work out perhaps a number from our frequency density. So I've got the graph that we've drawn here. Could I manage to get any data just by looking at this and see what we've got? Well, it's only going to work out if we knew what one of these is. If we know what one of these is, how many in one of these, then we could possibly work things out from there. So for instance, if I know that this number here in this 25 to 30 is 55, then I could work out how many in this one. Let's see how we would go about doing that. I know I've got a class width here of 5 and I've got a height of 11, and we can see that if I want to work out the number, or more precisely it is actually the frequency, if I've got the class width and I have here the frequency density, so I've got my class width here, I know it's 5, times my frequency density, 11, we can get our number 55. If I look at the next one and I don't know what this is and I want to work it out, we can measure this up here and say it's 7.8, and we know it's got a width of 5. So class width at 5 times 7.8, and I can work out that number simply by going into the calculator, and we can say this is going to be 7.8 times 5, and surprisingly it comes up with the answer 39, which is in fact the number that we had here. So we can backtrack on this, but we do need to know in each case how many were in each of these little lines. If I don't know how many are in the lines, then I can't work it out. Let's have a go at looking at interpreting another one of these histograms and see what we can do with it. Let's see if we can get some more ideas about what we can come up with. So what we need is another histogram with some data, and what we're going to try and do is we're going to try and draw this histogram and then perhaps try and get some data out of this. Now maybe my histogram doesn't exist as data, but maybe it exists only on this graph paper. So what I'm going to try and do is I'm going to try and draw and make up a histogram, and then we'll see if we can get some data from this. So let's start off with drawing out a histogram, and we'll go, I think, something like from 1 to 10. There's my line to draw, 1 to 10, and we'll put some numbers going across. Now this is normally what you'd be given, is one of these bits of things with data on here, and we can try to get some ideas then of what we might have to try and work out. Okay, so let's see if we can draw in some data. So this is going to be 1, 2, 3, 4. I've got some numbers up along the side, and we want to have some numbers along here. We'll do 1, 2, 3. And I've gone 1 to 12. Let me draw in a histogram. So this just represents some data of some sort, and we can have different widths, and these can represent various different things. We don't have to have all our class widths exactly the same. I can't imagine why anyone would try to have data looking like this, but ours is not to do that. Ours is just to try and work out the data on a histogram. And there we've got some data we can play around with. Doesn't mean anything to me, this stuff, nor would it mean anything to you, but you're going to be given a problem, and this one has given us a histogram with some weird data on it, and we're asked to try and work out something about this. So this is going to be again our frequency density, and this is going to be perhaps number of people. Let's see if we can work out what we've got. So this one here is, I've got 5 squares and it's by 2. So this one here, I'm going to give this some labels: A, B, C, D, E and F. So let's see what we can say about A. It's going to be 5 across and 2 up. So let's write some of these down. So it's 5 by 2, which is 10. Remember what we've got here. This is our class width times my frequency density, and that gives me my number. So that was for group A. For group B, we have a larger number. We've got here 10 across by 5 up, which gives us 50. So class width so here we've got 500. In group C, we've got 5 across and we're going up to 9. That was 5 up. Rather than 50, let's do this is going to be 5 by 9. And we can see that that group and that group are nearly the same number in area, although they don't look it by looking at the boxes. This is a much bigger one. This one goes from 5 to 9, so that's going to be 20 by 4. We've got E, which is 10 by 6. And finally we've got the last one, which is 5 by 2. So what I've managed to do is work out the frequency. So here is the frequency. Now let's suppose we find out that this number here represents 5 people. In perhaps some sort of age range or whatever it's going to be. So that's going to be 5. So 10 gave us 5. Well, we divide it by 2, so we'll need to do that with all the others, and typically I can see that's not going to work here. That's going to give me 22.5 people. That's always encouraging. That's where I just make up data. And I can then work out the number of people in each one. So we can interpret this histogram to try and get some idea. So we need to know some things, that what we're measuring along here, this normally is a continuous piece of data, whatever it is that we're doing here. Could be time, could be all sorts of things. The area of the bar is proportional to the frequency. So important, I'm going to write that one down. So the area of the bar is proportional to the frequency. And we've measured here, if you like, all of these, the area of the bar, and we can say that that area represents so many people. So we can start working out what these things might be. So we can look at a question and we can try to work out, perhaps, I know, if this is minutes people took to go to work. Whatever we're going to choose, it's going to be, and I want to know the number of people that took, perhaps, let's say, less than 5 minutes. So if I want to do less than 5 minutes, it's going to be all the people in C, all the people in B, and all the people in A. So I would then go here and say it's going to be all of those people. How many people took between 6 and 7? This is one of those horrible ones where we have to try and work out what that's going to be. So if I want to know between here 6 and 7, then we know it's in group, caught on the thing, in group D. So we've got our D, which we know is 4 high. So that's going to be 1 times, and that 1 is actually going to be 5 across, isn't it? 5 times 4, which gives me 20, and we know that 10 is 5, so therefore 20 is going to be 10 people. Who took more than 8 minutes to get to work? If I'm looking at more than 8 minutes to get to work, then we need to look at a particular number. Let's try a different horrible colour here. So this is going to be all the people that took more than 8 minutes to get to work. So it's going to be everyone in that bit plus everyone in this bit. Well, these aren't going to be too hard to find, E and F, because I've got those numbers already worked out. That's going to be 30 and 5. And for this one here, this particular one, it's going to be, we've got to work out what proportion of this it's going to be. We know it's 4 high, and we know it's 5, so 5 fours are 20, and that's the same sum as we did before. 5 fours are 20, that's 10 people. So I want to know things that are greater than 8, so we've got our 10 people from D, we've got our 30 people from E, and we've got our 5 people from F, and we can add those together and give us our answer 45. One of the popular questions you get in an exam is, can they put all of that together? And what they do is they give you a half-drawn histogram, and you've got to try and draw the rest. So you have to first of all interpret the histogram. You need to work out how many people perhaps are in here, and that represents that, so you can work out your sum, and then you can plot the rest to the same scale, working out, as we did before, our frequency density. Basically, that's most of the ideas about playing around with histograms. It's not really that difficult. They sound worse than they are. They do tend to cause quite a few problems, but as long as you keep a cool head, then they're not that difficult. So hopefully that's been useful. It's given you some ideas about how to draw a histogram and how to try and interpret data from the histogram. Next time we'll have a look at some more maths that people find difficult. If you found this useful, then please subscribe, and I'll see you next week. Take care, stay safe. Goodbye.